Earth magnetic poles are switching with catastrophic consequences for humanity. NASA scientists are warning us. John Austin of Express UK reports, the Earth could be left powerless to defend against blasts of solar radiation from the Sun for up to 200 years, leaving us at risk from skin cancer and worldwide electronic communications blackouts, NASA scientists warn. The space agency confirms fears that we may be heading towards an extraordinary event which would see compasses pointing south if the magnetic poles shift. They have done this many times in the past. We've even had the ancient priests of Egypt, telling and warning people, one of them being the ancient Athenian lawmaker Solon, who left a written record that he gave to Plato and passed down to us. And these ancient Egyptian priests knew that the Earth flips poles many times. It has done this many times in the past and will do so in the future. And it also has to do with a passing planetary system that wreaks havoc on the Earth. Now, whatever the case, the Earth does flip poles. The poles do move, and we see that happening, the magnetic pole especially, happening very quickly in the past few years. Now, climate researchers believe we're heading towards a reversal of the planet's magnetic field, an event that has happened before and has been attributed to wiping out the Neanderthal species. Bruce Jakowski, Maven principal investigator at the University of Colorado Boulder, said, when the switch does take place, the Earth's magnetic field, which prevents the sun's dangerous radiation getting through, would be neutralized for around 200 years. He revealed the detail during a historic announcement about how Mars lost 99% of its atmosphere and its oceans that could have housed early life. Jakowski explained that Mars had been blasted by solar winds, which had stripped it of its atmosphere, and for billions of years since the beginning of our solar system. He said when the polar shift happens, the Earth will have no magnetic field for about 200 years. During that time, the sun's solar blasts are expected to strip away at our atmosphere as they did on Mars billions of years ago. But he thankfully added that 200 years would not be long enough for the sun to significantly reduce the atmosphere for life to die out. Michael Mayer, lead scientist for NASA Mars mission, explained that the sun had been much more powerful in the early stages of the solar system, when Mars had been continuously blasted, and even when the process had taken billions of years and still 1% of its atmosphere remains. But scientists admit that 200 years without a magnetic shield to defend against the sun's solar storms, which cause the amazing northern lights on Earth, as the rays that hit the magnetic shield would have implications for us. The magnetic shield is our first line of defense against harmful UV ultraviolet rays, and any thinning of that atmosphere could increase the risk of skin cancer. Without a magnetic field, or with a significantly reduced magnetic field, it could destroy global communication facilities, power supplies, and even lead to fires and rioting on the streets, so social unrest basically because of earth changes, weather changes, and according to some researchers is what would be expected. It has happened in the past. There are even doommongers predicting that a swap of the magnetic poles from north to south would shift the continent so fiercely it would trigger mass earthquakes, rapid climate change, extinctions, and global destruction. Geologists said the swift shift event has happened a number of times in Earth's history, with the last one only 780,000 years ago during the Stone Age. Alan Thompson, who is head of geomagnetism at the British Geological Survey, said during previous flips no worldwide shifting of continents or other planet-wide disasters occurred, as geoscientists can testify to from fossils in other records. Earthquakes aside, there is a scientific belief that as we head towards a reversal, which could be less than maybe 1,000 years away, Earth's magnetic field could dangerously weaken, leaving us at the mercy of solar storms when radiation and X-rays are ejected from the sun towards our planet. That is, of course, coronal mass ejections and solar flares. In autumn, the UK reported there were fears if there is another major solar flare, as powerful as the last recorded strongest in Victorian times, trillions of pounds of damage could be done to the economy by power and communication blackouts. The most dramatic changes that occur when the poles reverse is very large decrease of the total field intensity. Jean-Pierre Vallée, who conducts research on geomagnetic reversals at the Institute of Earth Physics, said, but it's scientifically accepted. Our magnetic field has significantly weakened over the past 160 years. It's believed that this could mean we're heading for the next big polar reversal, which could happen any time. In 1,000 years to 10,000 years. It may take 10,000 years to finish. Space weather has shown that since 2014 up to 2018, our magnetic field of the Earth has diminished about 18%. If you extrapolate that to this year, it's about 23 to 25%. We have less of a magnetic field by 25% since 2014. Deadly earthquakes traveled at supersonic speeds, and why that matters. Supersonic. We talked about super shear earthquakes a few videos back. They go faster than the speed of sound, and that's where we hear sonic booms. Sonic booms. And sometimes we get that hearing, we hear that, we get the shaking, and then the huge earthquakes follows that boom. So it gives us a few seconds to protect ourselves and hide somewhere when these things strike. I'm in an area where we have a super shear fault that gives super shear deadly earthquakes, and there's another one, of course, in the San Andreas area of California on the west coast, and we also have them in Indonesia, we also have them in Alaska. Now, when earthquakes struck September 28, 2018, Indonesia, Sulawesi Island flowed like water. Currents of mud swallowed anything in their paths. They swept away entire sections of the city of Palo and cross-cutting the region's neat patchwork of crop fields. This is on Science of Cycles. I'll leave a link below for you for this, dated February 5th, 2019. Minutes after the shaking began, the locals were caught unaware by a wall of water that crashed on shore with devastating results. So yes, they do bring tsunamis. As the sun set that evening, thousands were missing, and within days the smell of corpses permeated the air. The 7.5 magnitude event was 2018's deadliest earthquake, with more than 2,000 people losing their lives from this. In the efforts to understand how this fatal series of events clicked into place, there's a lot of attention that has to focus on the surprise tsunami. But a pair of new studies published February 4th in Nature Geoscience tackles another remarkable aspect. The earthquake itself was likely an unusual and incredibly fast breed of trembler known as the super shear earthquake. The Palo quake cracked through the earth at nearly 9,200 miles per hour. You can understand that? It's almost Mach 9 times the speed of sound. 9,200 miles an hour. Fast enough to get from LA to New York in a mere 16 minutes. Such a fast rupture causes earthquakes, waves to pile up in what's known as a Mach front. It's similar to the pressure wave from a plane, traveling at supersonic speed. And this concentration cone of waves can amplify the quake's destructive power. Quote, it's like a sonic boom in an earthquake, end quote, says Wendy Bohon, an earthquake geologist at the Incorporated Research Institutes for Seismology, or IRIS for short. While it's not yet possible to say for certain if the super shear speed intensified Indonesia's quake landslides, the liquefaction, or the tsunami, a pair of new studies does offer a rare look at this little understood, potentially deadly phenomenon. Quote, we have observed only a handful of super shear earthquakes, and even fewer with this level of detail, end quote, said seismologist Jean-Paul Ampuero of Université Côte d'Azur in France. He was the co-author of one of the studies. Quote, this is going to tell us something fundamental about the way the Earth works, end quote, says Bohon, who was not involved in the study either. He said, and it has the potential to actually save lives, help us inform people in a better way, unquote. Unzipping the Earth during an earthquake, the entire length of a fracture does not break all at once. Rather, it unzips the planet's surface at a rate known as a rupture speed. Stephen Hicks, a seismologist at the University of Southampton of England, explains the phenomenon by grabbing a colorful flyer sitting on a table at the American Geophysical Union fall meeting in Washington, D.C. He makes a tiny tear on one side and says, imagine that's your nucleation, or the start of a rupture on a fault. The rupture speed is how fast that point moves through time, he says. And with a sharp jerk, he rips the flyer in two. Quote, it's this speed that caught geologists' attention with the Indonesia event. To take a closer look, Ampuero and his colleagues harness the power of the growing global network of seismic stations, and they detect the echoes of earthquakes from hundreds of miles away. So from that network, they collected the data from 51 locations across Australia. By studying the arrival of earthquakes, waves at each station, the team recreated the racing rupture, and it's similar to how your brain figures out where a sound is coming from, Ampuero explains. If someone's talking to you from the right, the noise arrives at your right ear a fraction of a second before your left. Your brain then uses that delay to locate the speaker. Quote, what we're doing is the same, but instead of using only 2 ears, we're using hundreds of ears, he says. Each ear is one seismometer on the ground. This revealed that the trembler broke so fast that the rupture speed overtook a type of radiation wave known as shear waves, thus the term super shear for a super shear earthquake. Over roughly 36 seconds, the quake cracked southward through some 93 miles of Earth's surface. 93 miles in 36 seconds. Quote, that is the ground breaking that fast, which is pretty amazing, quote. This is what Hicks marvels at, who was not involved in the research. It's an earthquake superhighway. A second team took a closer look at changes to the surface of the trembler ripping through, using data and imaging from satellites before and after the event. Quote, we were immediately struck by the sharpness of the rupture at the surface south of the city of Palo, and by the great amount of displacement in this area, end quote. Study co-author Anne Soquet of the Université Grenoble of the Alps in France writes in her email, magnetic north has changed. Here's what that means. This analysis suggests that the land largely shifted horizontally and that the change was massive, the ground offset by 16.5 feet at its maximum point south of Palo City. The shift was so large it was easily seen in images of region post-quake. Roads were offset, buildings seemingly were cut in two. Quote, this is definitely huge for a magnitude 7.5 earthquake, end quote, Soquet says. Quote, and this is likely enhanced by the fact that this earthquake was super shear, end quote. It didn't happen just at the surface either, but also as deep as roughly 3 miles underground. In the southern stretches of the fault, an important feature behind this rapid speed and the deep shift was that Soquet calls its maturity. Tectonics have tested this break time and time again. continually shoving the blocks of earth side by side and carving the fault into a fairly continuous, smooth, straight break, features previously associated with other examples of superfast, super shear earthquakes, the ruptures. Now, what is the anatomy of a super shear earthquake? Yet, even within this category of rare events, the Palo quake may stand apart. Most super shear earthquakes actually travel even faster than the one that took place in Palo, and they're also bigger. Now, cruising along almost as fast as another type of earthquake wave known as a pressure wave. These commonly zoom by around 11,200 miles an hour. So you see, it's about Mach 11. The Palu earthquake in Indonesia was Mach 9. So yeah, they could go faster. But Ampuero and his colleagues found that while the Indonesia quake was fast enough to be super shear, it did not hit this top speed of 11 Mach. It's extremely rare, he said, to see events in this intermediate range. Ampuero and his colleagues believe the discrepancy is due to the fact that earthquake models, including the one used in this work, commonly assumes that the rocks surrounding the fault are one intact unit, but that's not always the case in the real world, where zones of fractures around the break can slow the speeds of the quake's associated waves through the surface. So if true for Sulawesi, this would mean that the quake's pressure waves could have moved about as fast as its rupture speed, as is expected for super shear ruptures. The quake was still weirdly slow for a super shear, but at least its waves and rupture would have moved at the right relative speeds. But scientists won't know for sure that this was the case without more study in the region. It's not the only thing unusual about this event. September's earthquake also seemed largely undeterred by two major bends in the fault. Zigzags along the rupturing fault usually slow earthquakes, like cars on a winding road, but not this one. And unlike most super shear breaks, which need a little warm-up, the Palu trembler seemed to hit its galloping pace early on. Quote, "This earthquake is like a Lamborghini," Bonon says. "It goes from 0 to 60 in no time," end quote. This behavior raises even more questions. Could the fault be straighter and at depth, and would this have helped barrel through bending higher up? Did smaller foreshocks supercharge the big quake? This could have sent it galloping out of the gates, but this early speed could also have to do with the roughness of the fault, which could stick the sides together like the rough sides of sandpaper and cause the ground to break with extra oomph. Now, is there more to come? These unusual features make this earthquake all the more valuable, since they can help researchers better understand both where and how superfast, super shear earthquakes can happen. The scientists who reviewed the work all stressed the significance of this information for future modeling and hazard assessments, not just in Indonesia, but around the world. Quote, "What happened here could likely happen on other faults, especially major plate boundary faults. This type of fault is the same one we find in California." We're talking about the San Andreas fault, and northern Turkey, the northern Aegean, that's the Anatolia fault, and the Dead Sea fault, that's the one that's supposed to rupture before the coming of Christ. Quote, "Now, this earthquake geologist Sotiris Valkaniotis, who was not involved in the new study, says the detection from this earthquake applies worldwide." Now, my comment here in conclusion is that they did mention the pole shift, but unfortunately they did not go into that at all as to how that would affect the tectonic plates throughout the world. They do have that in their back of their mind. For them to have mentioned it in their findings in this article means that they probably believe this has to do with the increased volcanic activity and earthquake activity around the world, and even these huge fault lines that give the super shear supersonic quakes with the supersonic booms, but they did not go into that any further. Nevertheless, they did say that because of the pole shift moving so quickly at 34 miles per year lately, that could be an added effect to the increased seismicity around the world and on the forcing on the super shear faults on the tectonic plates and the volcanic activity. I'll leave a link below for you for this. Sudden jerks in the magnetic field of the Earth could be explained by the turbulent blobs found in Earth's core. This is on Live Science by Brandon Spector. It's amazing. We also have a video having to do with the changes that we find in the Earth's core, NASA video. What's astonishing is that at one point we almost lost all of the Earth's magnetic field, and also they claim that we've had many pole shifts. That's astonishing. Now, why is this happening? What has caused this? Earth's magnetic shield, as we know, defends our planet from the solar wind and cosmic radiation, making our life on our planet possible. But every 10 years or so, it can be a jerking event. Now, geomagnetic jerks, as they're called, are abrupt changes in the strength of the Earth's magnetic field. While some variations in the field are expected to occur gradually, slowly, over hundreds of thousands of years, these sudden wobbles in intensity last only a few years at most and may only alter the Earth's magnetism over specific parts of the world at a time. One of the first jerks documented, for example, briefly wrapped the field over Western Europe in 1969. Since then, a new jerk has been detected somewhere in the world every 10 years or so, and scientists still don't know what is causing this. While many geomagnetic phenomena, including northern and southern lights, the aurora borealis in the north as we know, result from electrified solar wind blasting into Earth's magnetosphere, and the jerks are thought to originate from deep inside our planet's core. That's where the magnetic field itself is generated by the constant churning of the liquid hot iron in the center. The exact mechanism of action, of course, is still a mystery about our planet Earth. Now, a new study published April 22nd in the journal Nature Geoscience offers a hypothetical theoretical explanation. According to a new computer model of the core's physical behavior, geomagnetic jerks may be generated by buoyant blobs of molten matter released from deep inside the core. Well, we know that recently that has been explained to be the reason why the North Magnetic Pole is moving from Canada towards Siberia. They claim that it has to do with a magma plume that was under Canada moving towards Siberia. That's taking the magnetism with it towards Siberia. Now, what is this jerk? In the new study, the researchers built a computer model that recreates the physical conditions of Earth's outer core and shows its evolution over many decades. After the equivalent of 4 million hours of calculation sped up thanks to a French supercomputer, the core simulation was able to generate geomagnetic jerks that closely align with actual jerks observed over the last few decades. Now, these simulated jerks jiggled the magnetosphere every 6 to 12 years in the model, but the events seemed to originate from buoyant anomalies that formed in the planet's core 25 years earlier. As those blobs of molten matter approach the outer surface of our Earth, the outer surface of the core, they generated powerful waves rushing along magnetic field lines near the core, creating sharp changes to the flow of liquid that governs the planet's magnetosphere. That's what the authors explained. And eventually, these sudden changes translate into the jerky disturbances in the magnetic field high above our planet. They say jerks represent a major obstacle to the prediction of geomagnetic field behavior for years to decades ahead. The ability to numerically reproduce jerks offers a new way to probe the physical properties of Earth's deeper interior. But it's impossible to confirm this simulation results with actual observations of the core, as we know it's too hot and high pressure to get anywhere near our planet's center, so this is just hypothetical. And having a model that can recreate historic jerks with high accuracy could be helpful in predicting the many jerks that will be coming in the future, as researchers wrote. So knowing when the jerks are coming could also help monitor how they affect other geodynamic processes. For example, is it possible, as one 2013 study in Nature magazine suggested, that the jerks are harbingers of longer days? According to that study, sudden changes in the fluid flow of Earth's core may also alter how the planet spins by the slightest bit, actually adding an extra millisecond to the day every 6 years or so. Periods where Earth's day lengthens seems to correlate with several established instances of well-known jerks, researchers said, and if that's true, the geomagnetic jerks are responsible for a slightly longer working day every few years. At least we know we've given them the right name. Now the thing is though, we've noticed that a few years ago when we had the Palo earthquake, the geologists and scientists told us that that earthquake was so strong that it took a couple of milliseconds off the day, so it shortened the day anyway. So we have changes in the magnetic field, as you'll see from this NASA video, many times during the past, and they've concluded this from studying the magnetic properties of rocks. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition and the community around our church. Thank you.